All right, section 11.7 talks about the counting principle and something called permutations. Okay, so let's look at the counting principle. It says if a first experiment can be performed in m distinct ways, and a second experiment can be performed in n distinct ways, then the two experiments in that order can be performed in m times n distinct ways. All right, so let's go through this first example and see if we can't make sense out of this. And it says counting principle, passwords. It says a password is used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. Determine how many passwords are possible if part A says repetition of letters and digits is permitted. Okay, so we're going to pick 2 lowercase letters, and then we're going to pick 4 digits. 2, 3, 4. Okay, so we can repeat the same letter. We can repeat the same number because it says repetition is permitted. Okay, so guys, English alphabet, there are 26 letters. So we can still repeat them. So it's not like if we use the letter C, we cannot use the letter C again. We could. So we'd still have 26 letters. Digits. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's a total of 10 digits. Okay? And we can keep repeating them. So what I'm going to do now is I'm going to take my calculator and I'm going to say, okay, what is 26 times 26 times 10 times 10 times 10, that's 3, one more, times 10, and we can do this 676 and then 4 zeros, 6, 7, 6, 1, 2, 3, 4. So this looks like the number 6,760,000 different ways you can make those passwords, right? Okay, so now let's do part B. Part B says repetition of letters and digits is not permitted. So we have 26 letters to choose from. Because we cannot choose the same letter twice, now we only have 25. Okay? When it comes to the digits, we have 10, and then we have 9, 8, and 7. Because once we use a particular digit, we cannot repeat it. Okay? So again, what that would sort of mean, guys, let me scroll a little bit here. If I were to use a 6, now I only have 9 digits to choose. And then I choose a 3, now I only have 8 digits to choose, so on and so forth, right? So let's go ahead and multiply these numbers out. So 26 times 25 times 10 times 9 times 8 times 7. And that's giving me 3,276,000. 3,276,000, right? Okay. And then part C says, let's see, the first letter must be a vowel, A-E-I-O-U, and the first digit cannot be a 0, and repetition is not permitted. Okay. So how many vowels do we have? We have 5, right? Okay. And we cannot repeat. So again, I can only choose from 5 there. Once I choose one of those letters, now again, guys, I only have 25 letters to choose from, right? The first digit cannot be a 0, right? So if the first digit cannot be a 0, how many numbers can I choose from? I can only choose from 9, okay? Then I cannot repeat my digits, okay? So suppose we pick a 7. Now we can include the 0. So we still have 9 to choose from the second time, 8, and then 7, right? So again, I'm going to grab my calculator here. 5 times 25 times 9 times 9 times 8 times 7. And that's given me 567,000 is how many different passwords we can generate, okay? So let's kind of keep moving along here. And let's see, t-shirt colors. So it says at Old Navy, a supply of solid colored t-shirts has just been received. The t-shirts come in the following colors: green, blue, white, yellow, and red. Billy, the floor manager, decides to display one of each color t-shirt in a row on a shelf. And how many different ways can he display the 5 different color t-shirts? Okay, so 1, 2, 3, 4, 5. Okay, so we have 5 colors: green, blue, white, yellow, and red. So in the first row, he can put any of those 5. And then once he chooses one, now he only has 4 to choose from. Then he only has 3 to choose from. Then only has 2 to choose from. Then he only has 1 to choose from. So now, again, I'm going to grab my calculator. 5 times 4 times 3 times 2 times 1. And that's given me 120. So 120 different ways he can do this for part A. Now let's look at part B. It says if he wants to place the blue t-shirt in the middle, how many ways can he arrange the t-shirts? Okay, so let's figure that out. All right, so 1, 2, 3, 4, 5. We know that he's going to put the blue ones here. So there's only one blue one. So now that he's chosen the blue, now he has 4 choices here, 3 choices here, 2 choices here, and 1 choice there. So again, I'm going to multiply 4 times 3 times 1 times 2 times 1. I don't need a calculator for this. 4 times 3 is 12, times 1 is still 12, times 2 is 24. Okay. All right. And then part C says if Billy wants the white t-shirt to be the first one, 4, 5, and the blue t-shirt to be the last one, how many ways? Okay, so we're going to have the white shirt here and the blue shirt here. So there's only one white, there's only one blue. Okay, so notice, then we still have 3 choices, 2 choices, and 1 choice, right? And again, we're multiplying. So 1 times 3 is 3, times 2 is 6, times 1, we still have 6 different ways of doing that, okay? Again, these are just doing what we call, trying to figure out how many ways can you do this. And so we're using this idea of permutations, okay? Okay, so here we go. What is a permutation? A permutation is any ordered arrangement of a given set of objects. Okay, so it says the number of permutations of n distinct items is called n factorial, symbolized by this. So guys, when I see a number with an exclamation point, it doesn't mean that I'm shouting out that number. This is what we call factorial. And the definition of a factorial is you're going to take that number and you're going to write it down, and then you're going to subtract 1, write it down, subtract 2. You're going to keep doing all that till you get to 1, and you're multiplying all those numbers out. So let me show you what we mean by this here. It says, in how many different ways can 7 different cars be arranged next to one another? So we have 7 different cars. 1, 2, 3, 4, 5, 6, 7. So the way we're going to do this is going to be what we call 7 factorial. What that means is the first spot, I have 7 cars to choose from. Then 6, then 5, then 4, 3, 2, and 1. Okay, so there is a way to do this on your calculator without actually having to multiply all those numbers out. And what you would do here, let me clear this. On this kind of a calculator, guys, I'll show you, you're going to hit 7. And then I'm going to go to Math. And if you look right here, it says PRB. The way I get there is I can hit my right arrow button 4 times. And I'm going to go to where it has the little exclamation point. So I'm going to go down to the number 4. I'm going to hit enter. So if you notice, it has 7 with the exclamation point. And here's my answer, 5,040. And it really, all we did is we took 7 times 6 times 5 times 4, all the way got down to 1. But my answer here is going to be 5,040. So guys, on your calculator, what I'm going to want to ask you to do is look for where you see that little exclamation point, okay? And I'll see if in a little bit if I can show you where you can find that on different calculators. All right, let's see. It says, for the next one here, it says permutations of 3 out of 5 letters. Consider the 5 letters A, B, C, D, and E. And how many distinct ways can 3 letters be selected and arranged if repetition is not allowed? Okay, so we're going to pick 3 of them, okay? So 1, 2, 3. The first time we can pick 5, then we can pick 4, then we can pick 3. All we're doing here is multiplying. So 5 times 4 is 20, times 3, 60. 60 different ways. Okay. Now, there is a formula, guys, and it says the formula, the number of permutations when R objects are selected from N is given by this formula right here. Okay. So it says use the permutation formula. It says you're among 9 people forming an astronomy club. Collectively, you decide to put each person's name in a hat to randomly select a president, vice president, and secretary. How many different arrangements or permutations of officers are possible? Okay, so we have 9 people, and we're going to pick a president, a vice president, and a secretary. So we're going to have a total of 3. So guys, I write it this way because the N is how many we have total. The R is we're selecting 3 of them, okay? Now, the other thing is on my calculator, I can do this again. So the first thing I'm going to do here, let me move this over, is I'm going to type in the number 9 because that's the first number I have here. Then I'm going to come back to my math button. I'm going to go back to my probability, which is 4 to the right. And I'm going to go down to number 2 because if you notice how it has that NPR, there's my NPR right here, right? So I'm going to go down right here, enter. And then my R in this case is the number 3. And there's my answer, 5,004. Again, I'll see if I can show you on other calculators how to do this as well. But you definitely want to get a scientific calculator that has something like that, okay? Let's see, example number 6 says, Prince George County Bicycle Club has 10 different routes. Members wish to travel exactly once, but they only have 6 dates for their trips. How many ways can the different routes be assigned to the dates scheduled for their trips? Okay, so we're going to go 10 dates, and we're going to select 6 of them. So again, I'm going to do this one more time on my calculator. So I'm going to go 10, then I'm going to hit math. So guys, instead of having to hit this right arrow 4 times, I can hit it once to the left. There we go. And then down, NPR. We're going to select 6 of them. And so I'm coming up with 151,200. 151,200. Okay. All right, it says to ATM codes. To use an automatic teller machine, you generally must enter a 4-digit code using the digits 0 through 9. How many 4-digit codes are possible if repetition is permitted? Okay, so 1, 2, 3, 4. Okay, so guys, remember the digits 0 through 9. 2, 3, 4, 5, 6, 7, 8, 9. There are a total of 10 of them, okay? And we can repeat, okay? So I have 10, 10, 10, 10. 10,000 different ways, okay, that you can make an ATM code. All right. Let's see, we have here selecting furniture. The Johnsons just moved in the new home and they're selecting furniture for the family room. They have 5 sofas, 2 chairs, 6 tables. They're going to pick 1 from each category. Determine the number of ways they can select the furniture. So we're going to take 5 sofas times 2 chairs times 6 tables. So 5 times 2 is 10. Times 6 is going to give us 60. So there's 60 ways they can sort of pick their furniture, okay? And that was 11.7.